Hi guys, so in this video we will be solving this problem, number of valid words. So let's first understand what the problem says. So according to problem, what will be given to us is that we will be given two lists. One list is what? A list of words, and another is what? A list of puzzles. Okay, and what we have to tell is that we have to tell the number of valid words for each puzzle. So you can consider number of valid words as some kind of score for a puzzle. So let's see how we have to calculate score for each puzzle. So let's one by one consider the puzzles. So the first puzzle is what? Above yz. Okay, so what this puzzle will do is that it will consider all the words. So all the words are what? A is one word, as is another word, able is another word, ability is another word, ACTT, and so on. There are some words. Okay, so this puzzle has to calculate the number of valid words for this self. So it will take into consideration all the puzzles one by one. Okay, one by one it will take into consideration. There are two conditions which are needed to be satisfied, which must satisfy. Okay, it will also maintain a counter with it. Okay, so first condition is that a particular word is means can be a valid word for a puzzle. This is puzzle and these are what? List of words. Only if whatever is the first character of the puzzle, that should be present in the word. So here the first character is what? A is present in the word also, so first condition satisfied. Now second condition is that whatever are the characters in the word, that should be, all the characters should be present in the puzzle also. So here there is only one character in the word, that is A. There are total 4 occurrences of A, but occurrences does not matter. I mean, we are focusing only on the number of unique characters. Okay, so the total there are 2 characters, one character, so that character should be present in the word. So A is present, so second condition also satisfied. Okay, so this particular word is valid for this puzzle, so our count will increase by 1. Okay, now this particular puzzle will move to the next word. So next word is what? ASAS. So again it will check both of these two conditions. So first condition is what? That first character of the puzzle should be present in the word. So A is the first character of the puzzle, that should be present in the word. It is present, so first condition satisfied. Now second condition is what? All the characters of this particular word should be present in the puzzle also. So A and S are the characters, so A and S should be present in the puzzle also. So let's check. A is present in the puzzle, cool. S is not present, so that means second condition is not satisfied. That means count will not be increased, and this particular word is not a valid for this particular puzzle. So now we'll move on to the next word. So next word is what? Able. So again we will check the first condition. First condition is what? First condition is that first character of this particular puzzle should be present in the word. So A is present over here also, so first condition satisfied. Now second condition, all the characters of word should be present in the puzzle. So A is present, cool. B is also present, cool. L is not present, that means our second condition failed. So this particular word able is also not a valid word for this particular puzzle. So we will move on to the next character again, and in this way one by one we will check all the particular valid words for this particular puzzle, and we will increase the counter whenever we get a valid word. Okay, now let's suppose that after calculating for all the valid words, what we got is that we got count equals to 3. So that means there are 3 valid words for this particular puzzle, so we will store 3 in front of this particular word. Okay, now we'll move on to now what will happen? We have done our task for one particular puzzle. Now we'll move to the next particular puzzle. This particular guy has done its task. Now we'll move on to second guy is what? Abroad YZ. Now it will also perform the same task. It will one by one consider all the puzzles, and it will check which all are the valid words for this particular puzzle. So first condition, again it will check the first condition. Whatever is the first character of the puzzle, that should be present in the word. So A is present in this puzzle, so first condition satisfied. All the characters of this particular word should be present in the word. So it has only one particular character, that is A is present in the puzzle. Second condition satisfied, count will increase by 1. So this particular is a valid word for this particular puzzle. Now we'll move on to second character. Again first character should be present in the word also. So first character is A is present in the word, so first condition satisfied. Second condition is what? All the characters of this particular word should be present in the word. present in the puzzle. A is present but S is not present, so second condition not satisfied, so this particular word is not valid for this puzzle. Okay, now we'll move on to the third character. Again we will check that whether all the two conditions are satisfying or not. So the first one is what we will check, that whether the first character of puzzle is present in the word or not. So first character is A is present in the word, so first condition satisfied. Second condition, all the characters of this particular word should be present in the puzzle. So A is present, okay. B is present, okay. L is not present, so second condition not satisfied. So this is also not a valid condition, a valid word for this particular puzzle. And so on. We'll move on and calculate the total number of valid words for this particular puzzle. Let's suppose answer came out to be plus 1, also answer came out to be 2, so we will store 2 in front of this particular puzzle. Okay, and now we'll move on to the next puzzle. So on, we'll move on to the next puzzle. We'll calculate for absolute, absorbs, actress, whatever it is. For all the particular puzzles we'll calculate, and we'll get, let's suppose we got something like this 2, 4, 0, 5 and so on. So finally what we have to do is that we have to return an array list of what these particular words. So 3, 2, 2, 4, 0 and 5 we have to return. So this is what we have to do in this particular problem. So this was for the problem statement for this particular question. Now I guess that you guys would have got an idea what we have to do in the problem. So now let's move on to the solution part. How can we solve this particular problem? Okay, so the way which I have discussed this problem till now is also a way for solving this particular problem, or likely this is the way which we are going to use, but we are going to optimize it. So what was the way that I was using till now was that one by one I was considering a puzzle. Above YZ was the first one, and I was scanning all the words, okay, and I was finding out like how many words are valid. I was increasing the count and I was storing it over here. Okay, but only doing this is not going to help us. Okay, why? Let's see. For that, let's see the constraints of this problem. Okay, if you look at the constraints, what we can see that that number of words are what, 10 to the power 5. So the words are 10 to the power 5 and puzzles are what, 10 to the power 4. So if we do this scan, what we are getting, we are doing something 10 to the power 4 into 10 to the power 5, which is roughly 10 to the power 9. And we are also doing some task in scanning, means whether this is valid for this we need to scan both the strings. So some work is over there also, but neglect that part. So we are getting 10 to the power 9, and we can easily there are very high chances that we will get a time limit exceeded for this particular if we do via this approach. So we need to optimize our approach. Okay, so let's see what all can we do to optimize our approach. Okay, so one thing is that let's suppose that there are some strings. There is a this is of what, 10 to the power 5, and let's suppose there is a puzzle ZMA. There is a puzzle ZMA. Okay, and there are only 3 words in this words list which contains a character Z. One of them is AMZ, other is BMZ, and second is CMZ. Okay, so for this particular puzzle there are also, we need to satisfy both of the two conditions. First condition is what, that first character of this puzzle should be present in the word. So only these 3 satisfy that condition, and then we need to satisfy the second condition. But for finding only these 3 strings, what I did, I made a whole traversal of this particular words array. So this traversal was like more or less very much, I was wasting my runtime on this particular traversal. Okay, now let's suppose there are many such strings, many such puzzles. Some puzzle like YMA, very few strings are there for this also, and there are let's suppose KMA, there are some strings like this. There are very few strings for it. So we are, what we are doing, we are actually wasting a lot of our time in simply scanning the whole word array. Like each puzzle, whichever puzzle we consider, A, B, X, Y, Z, first condition is what, that first character should be present in the word also. Then only we'll move on to the second condition. Then why we are checking for all the strings? We should only check those strings which contain the first character of this particular puzzle. So if I am considering A, B, X, Y, Z, then I will consider only those strings which contains a character A in them. If I'm focusing on ZMA for the moment, and I will consider only those strings which will contain a character Z in them. Then only I will consider, and I will not scan the whole array. So I can save some time over here. Like I can. So what I'm thinking is that what we will do is that instead of making the whole scan each time, what we can do is that we can maintain an hash map structure. What our hash map will store is that we will maintain an hash map. In hash map we will store in front of A, what we will store, all the strings which contain A in them. Okay, all the strings which contain A in them. In front of B, what I will store, all the strings which contains B in them. Same for C, same for D, and so on up to Z, all the strings which contain a particular character in them. Let's suppose that AS, let's take it as example. Okay, so this has a character A in it and a character S in it. Now I have two puzzles. Let's suppose I have a puzzle ABC and a puzzle SAS. Okay, so ABC, what does it means, that it can consider AS because it is passing the first condition. It is starting with A and it contains a character A. SAS, it can also consider ASAS because it is also passing the first condition for SAS also. Why? SAS starts with A, we can see, and our character string also contains S, so this is also passing the second condition. So what we will do is that I will scan a particular string, means word string, whichever character it contains, I will store it in front of them. That is, ASAS will be stored in front of A also, and in front of S also ASAS will be stored, because ABC can also use it and SAS can also use it. So if I maintain this hash map structure, I will be saving a lot of time. Like I will not be wasting my scans for each particular string. I will be wasting a lot of time over here, which I can optimize. Like there can be a puzzle or something like this. Let's suppose TUV, there is a puzzle, okay, and there is no word which is starting with T. So what will happen? I will eventually make a whole scan and I will find 0 strings. And instead of this, what I can do, I will simply go and check in front of T. I will see there are no strings present, so I will simply return from here. So I have saved my time of this scan of 10 to the power 5. Okay, so I'm saving a lot of time by maintaining this hash map structure. So let's do one thing. Let's try to make this hash map structure for now. Then after that we'll come back to here and we'll see what else we can do to optimize it further. Okay, so let's maintain a hash map structure for it now. So for that we'll need something like this, hash map of what? Hash map of character and hash set of string. Map 1 equals to new hash map. Okay, now for string word in words. Okay, now for integer I equals to 0, I is less than word dot length plus I, character ch equals to word dot character at I. Okay, okay, now map 1 dot get ch dot put what? This word. But before that we need to check one more thing. Yeah, we have done it over here, we have put it, then our work is done, right? But for that we need to first make sure that if map 1 negation map 1 dot contains key this what? ch, then what we will do, map 1 dot put new hash set. Okay, this is what we will do. After that, one more thing we need to do is that if negation, let's make that hash set of, let's do it something like this, hash set of string hs equals to map 1 dot get ch if negation hash set dot contains this what is this word, then only we will add it into our hash set. Let's remove this line for now. So hash set dot add word. Okay, so we are able to make a this structure. So what we are storing is character. In front of character, all the strings that are potential string that contains this particular character. So why I have used a hash set is because let's suppose this particular example a. Okay, so if we move into this, what we will see, first character is a. So in front of a, what I will store a. Now I'll again move it over here. Again I will see a, in front of a I will store a, but I am storing it multiple times. I need to store it only single time, so I have maintained a hash set. So even if I insert it multiple times, my hash set will store it only once. Okay, so yeah, hash set dot contains word we have added in the hash set. Okay, so this part is done. So we have done with this part. Now let's move on to the next part. So after this, let me erase this. Cool. Let me erase this. Can minimize this. Yeah, and we can store it somewhere over here, that we have this particular structure with us. Okay, now what we can do is that since we have made this structure, what we will do now, we have this list of puzzles like above yz, abroad yz, dot 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 up to gas w x y z. So what we will do is that now we'll again come back to our main logic. This is what the logic is that. So what we'll do, we'll consider the first puzzle a. What is the first character a in this hash map? What I will do, in front of a there are some list of strings. So what I will do, I will go to the first strings. Let in front of a, let's suppose a is there, able is there, ability is there, and so on. So what I will do, I will first go and check with a, then able, that all first condition is already satisfied because I am checking only the strings which are present in front of a, that is they already contains the first character of this particular puzzle. Okay, now I need to check only the second character, that is all the characters of the word are present in the puzzle or not. So first I will check with a that all the characters of a are present here or not. Now for able, now for ability, and I will check on go on checking, and I will increase my count. Okay, but here what we are doing, each time we are wasting the time in comparing two strings, like one kind of comparing strings. Now again I will go for abroad yz. Abroad yz also starts with a. Abroad yz will do what? It will also make the same comparison with all of these strings, like this able will be considered with above yz, with abroad yz, and all the strings puzzles which are starting with a. So can we do something over here, like can we save some time? So yes, we can save some time over here also. If we use like hashing and bit masking, we will use something like this. What we can do, we will do bit masking. Well, let's suppose our puzzles are what, made up of characters only a to z. So what I will do, let me assign some positions. I will assign a to 0, b to 1, c to 2, d to 3, e to 4, dot 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 up to z 25. Okay, now let's suppose I have a puzzle DAB. Okay, so what does it represents? I will represent it in forms of bits. So it means that it has a character b is at index 1. So 1 I will store at index 1. 1 represents that it has a character b. Now it has a character a is at position 0, so I will mark it 1. It has d is at position 3, so I will mark 1. Rest all are what, zeros. Okay, this is what I will do. Now let's suppose I have two puzzles also, two words also. One word is what, one word is bad, and another word is what, another word is BAC. These are the two words. Okay, now let me write the what in bit masking for this also. So if I write bit mask for bad will be what? If I write mask for bad, it contains character d is at position 3. So 0 1 2 3, 3 will be 1, and it has a position a is at position 1, b is at position, a is at position 0, b is at 1, and rest all characters, it does not have any characters, so rest all characters will be 0. Okay, now let's write the bit mask for DAB here also. Here it is what, DAB 001 011, and it is BAC. So B is at position 1, C is at position 2, A is at position 0, the rest all are what, 0. Okay, so I have written something like this. Now first let's analyze it like this. Later on we will derive a formula like how we will able to calculate it. First let's see manually only. If we see what is the our what do we need to satisfy second condition, that all the characters in the word should be present in the puzzle also. Okay, so if we look at the bit mask of the word, if a particular character is 1 at a position, and if at that position the character of puzzle is 0, that means that character is not present in the puzzle but it is present in the word. So simply it means what? Fail. We need to fail it. Okay, the same if we see that if we, let's see it in example. Here all the positions where there is a 1 in the word, it is word and it is puzzle. The same positions are also 1 in puzzle also. So that means what? Whatever characters are present in the word are also present in the puzzle. Then according to the rule, this should satisfy the condition. This particular example should satisfy the condition, means it satisfies the second constraint. So we need to add a plus count, we need to increment our count for this particular word. Okay, now let's see this particular word. In this particular word, what we are seeing, all the positions B, A, C. Oh, there is a mistake over here. It will be 1 over here also. B, A, C. Since it is B, A, C. Yeah, so now let's continue. So if we look at all the positions, here there is a 1 present in the word. That means what? C character is present in the word, but here it is 0. That means what? C character is not present in the puzzle. So according to the constraint, all the characters of the word should be present in the puzzle, but here it is not the case. Then it should fail, means this should not be a valid word for this particular puzzle. Okay, so how will we get this? Okay, so if we see that if we perform the bitwise AND of these two numbers, if we perform the AND, let's perform the AND. What we are getting? We are getting 1 1 0 1 0 0. If we perform the AND, we are getting 1 1 0 0 0 0. Here if we see this AND, this particular AND and this particular AND, these are exactly the same. And here this AND means this mask of word and result we are getting, these are what? Not same. Okay, so if this result is same, then it means what? We can increase our counter, we are satisfying the second condition. And if result is not same, then it means what? This is not a valid word. So we can use this. What we will do, we will calculate, means we will perform the AND between the mask of puzzle and mask of word. If we are getting the same result as the word mask, then it means what? Both are, means puzzle and word contains the same characters. That means second condition is satisfied. And I have told you the reason, like if at both the positions all the bits are 1, then and result of AND will be what? Same as the word only. Okay, that is why we are getting the result same as AND also. So this is what we are going to use. Instead of, means each time scanning this whole, after scanning this array, we will not each time compare each string. Instead what we will do is that, let me erase this a little bit first. So what we will do is that we will scan for puzzle A, we will scan all the characters of A. But what we will do is that we will simply do, if puzzle mask of this puzzle and word mask of this word, whatever this word is, if it is equals to word mask of word, then what we will do, we will increase our counter, otherwise we will not increase our counter. So for calculating puzzle mask and word mask, like I have explained you just before, what we saw, that we need the puzzle for each word, word mask for each puzzle and mask for each word. Okay, so let's do one thing. For now, this is the main formula, this is what we are going to apply. But for using this formula, we need to calculate the puzzle mask and word mask for each puzzle and word. So what we will do, let's maintain an hash map of what? String comma integer, in which we will store for each puzzle, we will store its bit mask. Similarly, an hash map of string comma integer for this puzzle mask, word mask also, in which we will store the puzzle for each word. Okay, after that we can apply this particular logic. And yeah, we need one more thing, like for A I am reserving 0, for B I am needing 1, for C I am reserving 2. So for this also let's make an hash map for what? Character comma integer will help us, character comma integer for this particular task. So let's make 3 of these. So what we need, let's do one by one. So we not like this, we need a hash map of what? Character comma integer. Hash map of character comma integer map 2 equals to new hash map, in which we will store that a means 0, b means 1, that is what we will store. Let's make a character ch equals to a. Okay, for integer I equals to 0, I is less than 26, what we will do, plus plus I, and we will put map2 dot put map2 dot put ch comma I. Okay, this is what we need to increment our ch also, so we will do ch is equal to what? Ch plus of 1 each time, and let's typecast into character also. Okay, typecast into character also, map to the put ch comma I. Okay, so we have done this, we have calculated this hash map for abc. Now we need this word mask and puzzle mask, like what is the mask for each puzzle and what is the mask for each word. So for that also let's make two hash maps. So hash map of what we need, string comma integer. Okay, well, let's name it word mask. Word mask equals to new hash map. Okay, now same thing we'll be needing for what? For puzzle mask also. So let's write puzzle mask equals to new hash map. Okay, so we have word mask, we have puzzle mask. Now let's calculate the mask. So for string word in words, okay, for integer I equals to 0, I is less than word dot length plus plus I, character ch is equal to what? Word dot get word dot not word, yeah, word dot get caret 0. It is word dot caret 0, word dot caret 0, not 0 I, word dot caret 0. Now we will do, let's make a variable integer mask equals to 0. Mask will be what? Mask will be equal to mask or one left shift map 2 dot get ch. Cool. After this what we will do, we need to put it back. So what we'll do, this word mask dot put word comma mask. Okay, so same task we will do for what this puzzle mask also. So let's do that also. For string word in, here it will be what? Puzzles mask equals to 0. See what character of a map to get ch. Finally it will be what? Puzzle mask. Puzzle mask dot put. Okay, so now we have done with what? We have this puzzle mask for each puzzle, we have word mask for each word. Now what we have to do, we have to, for each one by one we will start for each puzzle. For each puzzle we will look into all the valid, means all the valid strings, all the words for which first character is same. Okay, for them what we will do, we will apply this logic. If it is true, then we will increase the counter, means it is satisfying the second condition, otherwise we will simply skip it. So let's do that. So for string puzzle in puzzles. Okay, now for string word in what? Words. Okay, now what we will do, one by one we will, means find the this, whatever is this word, not like this. We don't want all of these, we want only the valid words. Like if you are considering above yz, then I don't want all the words. Now I want words which are stored in my hash map, so we will not consider all the words. What we will do, only those words. So for string word in this map1 dot get puzzle dot character at 0. So puzzle.character at 0. Okay, now what I have done is that for all the puzzles, what are the valid words? Those words which contain character A, and in this hash map I have stored the strings which contains the character A. So this is what I have done over here. From the hash map I am getting only those strings which contains the character A. Okay, so if it contains character A, then what you have to check? I have to check only this. If it is true, then I can increase my counter. So let's make a variable counter equals to 0. So what I will check, if word mask of if word mask of this particular word, whatever is the word in consideration, and puzzle mask of puzzle, if it is equals to word mask of word is, and puzzle mask of puzzle, if it is equals to what? Word mask of word. If it is true, then what we will do? We will increase our counter. Okay, let's check whether all the brackets are correct or not. So this one for the last one. Okay, and and this bracket is also correct. Then we will increase our counter. Okay, we need an array list also, since we have to return an array list of integer. So let's make array list of integer arr equals to new array list. Okay, so we have made an array list. Okay, finally what we have to do, we have to add it into the array list. So array list dot add what? This particular count. Finally we need to return the count. Okay, but we need to manage some things, like there can be there can be cases where our map one does not have this particular character, so we need to maintain that case. So if negation, if map one dot contains key particular, this what contains key puzzle dot character at 0, then only we will do this. Okay, so for this, yeah, then only we will go inside this. Otherwise what I have done is that, like there can be cases like this, like for all the words we have stored, like there was no word which containing a letter, there was no word which containing a letter Z. Okay, let's suppose, and there is a let's suppose G in this case. So there is no word which contains a letter G. Okay, but there is a puzzle with which is containing G. So if I simply try to access G, so I will get null pointer exception. So to avoid that, we have written it over here. Okay, so I think we are more or less almost done with the code. So let's try to run this code. Let's see if there is any error or if it is working fine. We have written, so yeah, there is some error. New hash map map one dot put new hash set. There is some error at line number 14. What we have done wrong? New hash set. Okay, hash set map one dot put new hash set. Yeah, method put in map one dot put. Yeah, it is what? ch comma new hash set it will be. Okay, after that line number 30. Where is line number 30 for integer? Yeah, it will be this. Okay, now let's try to run it. 41 also same issue, we have copy pasted the code, it will be same issue. Now let's try to run it. Okay, cannot find symbol with symbol. Word mask, you cannot find word mask. Word mask cannot be find. Word mask. Okay, here it will be return array. Okay, return array. Word mask cannot be find. So we have defined word mask, right? That word mask equals to new hash map, puzzle mask equals to new puzzle mask. So word mask dot put, puzzle mask dot put. So if word mask, okay, word mask dot get, it will be dot get word, and puzzle mask dot get puzzle mask equals to word mask dot get word mask. Okay, anything else? Now let's try to run this code. We are getting correct answer. Let's try to submit it. Let's see. it is passing. So that's it for this question. So I hope you guys would have understood the solution.